Welcome to our first class in a course called Mathematical Analysis. So below is a course content of what you are required to know by the end of this entire course. So the first unit is that of sets or set theory. So we're going to define the basic operations of sets. We're also going to look at the set identities, the Morgan laws, a set of numbers, real numbers, complex numbers, and we'll also look at arithmetic operations in complex numbers. We'll look at the surd and the application in business. Then we'll look at unit 2, which has equations and inequalities or inequations, where we're going to discuss simultaneous equations and how to even plot equations. So we're going to look at the non-linear and the linear equations. We're going to look at expressions of equations using fractions, linear equations, and quadratic equations. After, we'll look at functions. This may also slightly be called mathematics for economists. So we're also going to look at functions, how to draw graphs, and how to do the plotting using the function. Unit 4, we'll look at the types of functions, the linear and the non-linear and the applications. Then we'll look at mathematics of finance, differentiation, which will slightly be the toughest of this syllabus. I must mention that this course requires effort. So I usually give some homework or you've been hearing me? I was on mute. Can you hear me?
Yes.
Yeah.
So basically, this is how the outline is. So for you, you basically need to know what is involved in syllabus. That's the first thing you need to know. So I'll start with set theory as our first topic. So let's start with sets. To start with, in your own understanding, what is a set? What do you think is a set? Anyone? What is a set? Anyone? Set can be defined as a collection of elements, can be a selection of numbers, can be a selection of functions that have a common representation. So sets are usually represented by a list of members, and these ones are usually closed in brackets. So we have different types of sets. So a set of numbers, real numbers could be 1, 2, 3, 4 upwards. That's something in common. About a set of prime numbers. What are prime numbers? Numbers that can only be divisible by 1 and itself. 1, 3, 5, 7. This is also a set. All right. Let's be a set of what? Fractions. Can be a set of powers. 1/2, 1/4, etc. But usually we close them with brackets. So this are what we call sets. Now, the best definition of a set is that it's a collection of well-defined objects. So these objects may have something in common. So what is the meaning of well-defined? When we're talking about well-defined, we're looking at specific and clearly stated objects. I may ask, if we have a universal set which has numbers from 1 to 10, can somebody give me a set of even numbers? This is a universal set. Somebody give me a set of even numbers. Can somebody give me a set of odd numbers? Can somebody give me a set of prime numbers?
Even numbers is 2, 4, 6, 8 going forward.
2, 4, 6, 8, and 10. Okay, who can give us a set of odd numbers? Odd numbers.
Odd numbers is 1, 3, 5, 7, 9, 11.
1, 3, 5, 7, 9.
Going forward, yes.
Up to 10 within the universal set. What prime numbers? Numbers divisible by 1 in itself. Which ones are the prime numbers in here? One, 3, 5, 7. How about 9? Is 9 a prime number? No, because 3 can go. Now, which numbers are divisible by 3 from 1 to 10? Which numbers are divisible by 3?
3, 6, 9.
3, 6, and 9. Which numbers are divisible by 5?
5 itself and 10.
5 itself and 10. Right. These are set notations that we want to look at. So these are odd numbers. We call this, we can call this even numbers E, numbers O, numbers P. Divisible by 3, we can use letter T if you want. Divisible by 5, we can use letter F. So I want us now to come up with a few notations here. We'll be asked, for instance, to find the set with the following signs. Sign means intersection. Intersection means what is common between the two. Okay. You can tell us what this one means.
Union.
Union, correct? Unite is to do what? To add.
To add.
Intersection, what is common? Okay. Then we have 2. A is a subset of B. Is a subset of what? B. All right, so we want to now come up with notations from our example that we had. Those of you who have just joined us, we said may have a universal set which has numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You'd be told that of these ones have prime numbers. Numbers are numbers divisible by 1 and itself is 1. Which other numbers are prime numbers? 3,
3,
5, 7.
7.
Odd numbers can use O. Numbers are all odd. 1, 3, 5, 7, 9. Which numbers are divisible by 3? 3, 6, 9.
9, 12.
Numbers are divisible by, that one is 10, by the way. So university said 5 and 10. And finally, which ones are the even numbers? 2, 4, 6, 8, 10. We're going to look at a few notations here. They're going to ask us now, for instance, part A, find the intersection. Find intersection of E intersection E. What does it mean? What is common between T and E?
Six.
It's correct. And they'll ask you maybe B, find the complement of P. Complement is what is not there in P. What is a complement of P? Based on the universal set, what is not there?
2,
4, 6,
4, 6, 8, 9,
9.
10. 10.
And we got to what is a intersection of O intersection E, you unite it to F. What is common between P and O? 1 is 1 there.
1,
3,
3,
3,
3 there.
3, 5,
5 there.
7.
7 there. Okay. 9 is not there. So here we're going to look at what? 1, 3, 5, 7. Then we compare it now to the F. What is common between? We unite it, right? So union.
Yes, which is 1, 3, 5, 7, 10.
7.
Okay. All together. So suppose we're being asked to find O intersection E. O intersection E. What does it mean?
The things which are common between O and E. It's an empty set.
So how do we denote an empty set?
It's either you write the 2 brackets or 0, like a letter O and cancel it.
Okay, great. Many people have been studying. Yes. So I'm going to write it in 2 ways. An empty set looks like this, or we're going to write something like that, meaning there's nothing common. All together. We're going to go briefly to
Yes.
what we call a Venn diagram. What is a Venn diagram? Venn diagram looks like this. I need you to tell me my shaded things, what is represented by figure 1, what is represented by figure 2, A and B. What is represented by figure 3. Can somebody tell me what is in figure 1, what is in figure 2, and what is in figure 3?
Figure 1 is an
Figure-
intersection.
Yeah.
1 is A intersection B. Figure 2,
Maybe A complement B. A complement B. Yeah.
A union B complement.
A union B complement.
A
That's figure 2.
B complement. Okay. Anyone else with a different view?
Can
That's
even
just
be
A
A
complement.
intersection B complement.
It's just a complement.
Yes, just A complement.
Okay.
Just A complement. Well, what does complement mean? What is outside?
What out there?
Yeah. Okay. What is outside a particular? So it's just A. That is simply A complement. How about last part? Figure 3.
A union B.
A union B. Is she right?
Yes. Yeah.
Okay. So if you've understood that, try to look at this notation here. Suppose we're given the following. A 2, 4, 6, 8 B. So let's find union B. Let's find A intersection B. Want to try A union B?
A union B, it's 2, 4, 6, 8, 10, 12.
Mhm.
You right?
Yes.
4, 6, 8, 10, 12. What A intersection B?
A intersection B is
6, 8.
6 and 8.
6 and 8.
6 and 8. All right. Now suppose we have a class of 20. Those that take English are 5. Those that take math, those that take physics are 7. English intersection math, because we have 3. Math intersection physics, because we have 2. We have 5. Then English intersection math intersection physics. We have 2. At A, let us draw the Venn diagram. Who wants to help us draw? Right. So here, let me just make an adjustment. Let me increase these figures here. So that's interesting. We have 18. We have 15. Here we have 20. And here we have 65. We have English, we have math, and we have physics. Where do we start from? All of them
We
enter.
start from C intersection B.
So we start
C
from
intersection M intersection P equals to 2.
we'll start from there, right?
Yes.
Yes.
Then English intersection math is how much?
It's 16.
English intersection math is what? 3.
Mm,
All right.
mm.
Then English intersection physics is 4.
Is 1.
What do you put here? English intersection math. He says 1. Where are you getting the 1 from?
1. Yes,
Since we already have the 2,
We have a 2. It makes 3. How about here? What do we put?
A 1.
3.
A 1.
3. Where do you get the 3?
5 minus
3.
5 minus 2.
5 minus 2.
How about here?
Okay.
That's 2.
Where is it where are you getting the 2?
4 minus 2.
4 minus 2, correct. Are we together so far here?
Yes.
Right, so let's go to English. What are we going to put in here?
I'm going to put 13 there.
13.
Where do you get the 13?
We are subtracting the 5, the 5 from the 18.
Here, what are we going to put?
Nine.
9. Where are you getting the 9?
We are subtracting the 6 from the 15.
Here, what are we going to put?
$13.
13.
And where are you getting the 13?
We're
20
subtracting
minus
the
7.
7 from 20.
What are we going to put outside here?
Mm, 13, 36.
13, 15, 20, 65.
What about 22?
22.
22.
All right. So we're going to get the 22. How are we getting the 22?
We are adding all the numbers.
Hmm.
Then we subtract the total from the 65.
Okay. One lost so far? Anyone lost so far? So my question is, what is the complement of? But A, find, give me E intersection. Give me E intersection. E. But E, give me E complement. C, give me M union P union P. That's is 3. Let's see if they're following.
So for A, it's 2.
Then but
Is it correct, sir?
it's correct. It's actually already in the question there, so it's correct. Mhm.
Yes, sir.
Then
Sir,
Is it not 22? Just right.
A intersection E intersection P intersection P 4.
Yes.
Been given here already. It's 4. Okay. I'm starting from what you know to what you don't know. So I'm sure most of you, one of the tricky questions when they come like this, I don't know whatever goes in your mind. In a class of 36 students, 8 do math, 20 do chemistry, 5 do neither. How many students do chemistry but not mathematics? Now this is 10 marks. How do we go about this?
Use a Venn diagram.
This is the diagram, okay? So how does it go? You need us
I want to do a Venn diagram with two sets which represented by maths and chemistry.
Okay, so let's do a Venn diagram. Okay. Sets according to one of you. So so what are we going to put here? Math and chemistry. Then
Then we start with the intersection.
start with the intersection. Isn't the intersection?
Looks like it's an empty set.
Has a lot of thinking.
We'll start by instead not putting 5 outside, because 5 is not, it's neither in those sets, the 2 sets.
In a class, let's move step by step. In a class of 36, and 8
Yes.
maths, all right?
Yes.
And 20 chemistry. So maths are how many? 28.
They are 28.
In chemistry, how many are they?
20.
20.
So we'll be subtracting later on. And 5 do neither. Where are we going to put the 5?
Outside the set.
Outside.
Outside.
The total must be equal to what? The total must be equal to what?
26.
Must be equal to 26. So when we add 8 and 20 plus 5,
48.
what we have in total here?
53.
What
The
have we-
total is 53.
That was what?
53. 53.
53. So how are we going to treat that?
Sir, can you get me? Sir,
Mhm.
so you subtract with the total. So you subtract 36 minus 53 minus 36. Then our answer will be 17, which will be our intersect.
When we subtract 3 minus 36, then what are we getting?
17.
17. You put 17
Mhm.
here, what we do?
Yes.
Subtract here.
So when you subtract 28 minus 17, it will give you 11.
Here.
Then the other side, when you subtract, it will give you 3.
Give you what?
3.
So when we add 5 plus 11 plus 3, what do we get?
36.
We get 36. Now,
Yes, 36.
now what's the question here? How many students do chemistry but not mathematics? How many students do chemistry but not mathematics? How many are they?
3.
That's 3.
3. There are 3.
Yeah, 3.
3. Yes.
What about the 5 outside the set?
That is
They don't doing any of
Do
them.
neither.
is 3. And max, okay. That's correct. You guys already know this stuff. I don't know. Let's try this now. In a class of 40, the 6 students say like hiking, 28 say camping, and 20 say so. They like both hiking and camping. Are there any students who do not like either hiking or camping? If so, how many? What are we going to do here? We do a Venn diagram of what?
Okay, 2 sets.
Which are?
Hiking and camping.
Okay, hiking, camping. Okay. What else have we taught?
Then we include the intersect, which is 20. They like both hiking and what, 20.
So 20 here.
Then we
26.
sub
6 minus 20.
So 6 minus 20. What is that?
which is 6.
It's for hiking only.
Okay. So hiking, we're going to get what?
6.
6.
And 6 minus 26. Then camping. Camping. What do we do to get the camping?
Subtract 20 from 28.
Okay. 28 minus 20, get what?
8.
Huh? Then what follows? We can now answer the question. So what's the question? So here's the question. Are students, any students who do not like either hiking or camping? So the total students must be how many?
40.
40. Okay. So 40 must be the inverse of set. So what must be the inverse of set? So to find what is outside, we're going to do 40 minus what?
34.
Total number of
6 minus 20
sets.
plus 8. What does it give us?
34.
Give us 6.
To give us 6.
We have 6. So what is the 6? Outside here. All right. So 6 is a number. The question is, are there students who do not like either of the two? Yes. How many? 6. So 3 marks and 3 marks. Right? Are we following? Anyone behind?
Yes.
Yes.
Anyone who's left behind? Well, so we started with the basics. We're going to slightly complex so that we can reduce this. So let's try this question now. Given the following data. Study of 90 students shows that 25 love maths, 41 physics, 2 chemistry. Among those who love maths, 12 love physics and maths, 12 love physics, 7 love chemistry, and further 5 love mathematics, love both physics and chemistry. Finally, among the students surveyed, 24 don't love any of the subjects. So let's do the notation. So we're going to move like this. I want everyone to participate. We'll start with Dongom, Kosha, and Mtale. Then Mila, Abraham, and Axon, Carol, Graham, and Helen, and Ron, Maggie, and Maya. Let's move in that direction. What do we do? Let's set, illustrate in the Venn diagram. What are we going to consider? And find the sets that are there.
There are going to be 3 sets for maths, physics, and chemistry.
Maths, physics, and chemistry. Okay. Maths, physics, and chemistry.
The first thing we are going to do is we are going to look for those who do not take anything, those who are found outside those sets.
Is it right?
No.
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 What do we do first?
The first thing
Is the
we need
The
to
intersect.
of all the
of
sets.
for 3 sets.
Okay.
No.
For the 3, which one is the intersect for of all the 3?
Yes.
We find the intersection of all the 3.
5.
It says
5.
So 5
Oh.
of them there.
5.
Then you find what's common for physics and chemistry, as well as mathematics and chemistry, the intersection.
Okay. So let's identify them. So the 5 have all of them. This is where the 5 is coming from.
Mhm.
One that love pairs. So which ones? Physics and mathematics are how many?
So let's see, 41
So-
love physics.
Maths, intersection physics is what? 12, right? It? Physics. Those who love mathematics. Among those who love mathematics, who love physics.
12 love physics.
Okay. So meaning this is the intersection of what?
Of maths and physics.
And physics, which is 12. So 12 minus 5, what do we get?
5, 7.
7. Right? So English is the prerequisite here. Among those who love mathematics, 12 love physics. Among those who love mathematics, 7 love chemistry. So mathematics, the section what? Chemistry
Chemistry.
will be what? 7 minus
25.
which is what?
2.
So we put the 2 there. Then among those who love, then we went further, say 5 love both mathematics, chemistry, and physics. So what do we put here? But 1 love physics and 2 love chemistry. But
22 love.
I want to look for this one here. What do we get in this column?
Isn't it not 12? We say 12 love physics and 7 love chemistry. Isn't it not 12 less? There's the 12 that love physics and 7 love chemistry.
Among those who love mathematics, meaning besides loving mathematics, among those who love mathematics, 7 love.
Chemistry.
Among those who love mathematics, 12 love physics. So among those who love mathematics, 12 love physics. So mathematics and physics in short is 12. That's where it's coming from. Among those who love mathematics, 7 love chemistry. So mathematics and chemistry in short, the total must be 7.
Sure.
What we want to know is physics and chemistry. So we are not taught that one is what? Blank.
X.
We'll get back to that. The study had what? 90 students. So let's just say to what? 90.
90.
And 5 love mathematics. So mathematics must be what?
25.
So M should be 25 minus what?
7
Minus
7.
minus
5.
5 minus 2.
What do we get?
14. That's about 11.
Okay.
11.
And we go to chemistry. What are we taught here? 41 now what? Physics. So let's go to physics.
15.
Physics. There is 41 love physics and 22 love chemistry. Okay. What do we do there? I taught 1 love. 41 love what?
Physics.
Physics.
So physics will be 41 minus what?
41 minus
5 minus 6.
This is what?
Minus x.
Minus 8.
12.
Good minus x, correct. If we don't know yet, yeah. So what are we getting here?
34 minus 6.
What?
34 minus 6. 9.
34?
Minus 6.
24 minus x.
Wait. Okay.
29. 29.
29.
29 minus x.
9 minus x. Okay. How about in here?
29, yeah.
You were told what? I mean, love.
That is what I said.
Yeah, it's 15 minus x.
22 love chemistry. So
So this is
22
29.
minus 2 minus 5 minus 2.
Chemistry will be it's 2 minus what? 5
Minus 5 minus 2 minus
minus
x.
Yeah. 15.
15 minus x.
we get 15 minus x.
Mhm.
All right. So what else are we taught?
24 do not have any of the subjects.
Students. 24 did not have any of the subjects.
4 did not have what?
Any of the
Any
subjects.
of the subjects.
So what do we do?
We write the 24
And put it-
out outside the what's this?
The 3
The
sets.
sets.
And 4 here.
Mm.
So,
So
mhm.
for us to find the total to find the value of a, oh, am I correct?
Yes.
Yes.
Mhm.
Okay, so for us to find the value of x, we are going to add everything.
Mhm.
which X, madam?
The
Both
x
x's.
in physics and
Chemistry.
chemistry, but we're supposed to add everything, then equals to the total number of students, which is 90.
All right.
You haven't put the 15 minus x in the chemistry set.
Here is supposed to be 15 minus what?
Yes, minus x.
All right. So we're going to find so 90. We got what? 90 must be what?
All the,
Sorry,
all
I've loved,
the,
we can't see the diagram.
all the elements in the set.
Okay.
90 on the other page. So
Plus.
90 is equal to what?
Yes.
24
Plus
plus.
plus 11
4.
plus 2 plus 5 plus 7.
Okay, so I can wrap them here so I can write. Okay. Okay, so let me wrap this up. Since we've already done the workings. Right. So 90 must be equal to what?
Because
24 plus 11
Plus
11 but
11
plus 2
plus 7
plus 7
plus 5
5
plus 2
plus 2
plus 29 minus x
plus 29 plus x
plus x
15.
plus x
plus 15 minus x.
plus 15 minus x. Mhm.
Are we adding the 24?
Yes.
Yes.
4 plus 11
Okay.
plus 7 plus 5
Plus 5
plus
93.
plus
93.
29 plus 15 to 93.
Yes.
And this x and that x will cancel. We're just going to remain with minus x. This x goes this side, the positive. This one will be what?
Mhm.
So We get people are intelligent. Oh yeah,
So far, so good.
I don't know why. So this is how we get the 3. Carrying about. So our x is equal to 3. We can withdraw now this. This point, is there anyone behind? Are we together?
So I made it behind.
Where are you behind?
Like where we came up with the x in the brackets.
Which one? Which x? This one?
Yeah, the triple x, all of the x's in the brackets or in the diagrams. Yeah,
So
in the Z.
we were not given the intersection. The examiner hid information, intersection between chemistry and physics. So we just put in a figure. So of each one of these ones here, we're taught, say, the intersection between mathematics and chemistry was 12. So 12 will have mathematics, also have physics. We're also taught the intersection between mathematics and physics to say, mathematics and chemistry to say 7 have mathematics, also have chemistry. But it was silent. Tell us those will have physics and chemistry. So we had everything else. So we had to improvise. We put a letter X, can put a letter Y, whatsoever. So this was a lot of thought, thinking out of the box. This was 7 marks. That's how we put X there. So meaning whatever is there, we subtract X. Whatever is there, subtract X. And we are also taught that those that don't take anything are 24. So we came up with an equation to say we know that the total must be equated. So 90 must be equal to everything in here. So that's how we added. We came up with an equation which eventually gave us the value of X to be 3. Now we can withdraw this diagram to be as follows. You're going to have what? 11, 2, 7, 3, 12, 20 what? 26. So this is very good here for marks. So now help me. How many students love mathematics but not chemistry? How many love mathematics but not chemistry?
Yeah, 11.
No,
Oh,
13. 13.
Why did you get a 13?
Ah,
How many love what? Mathematics but not chemistry.
maths, but not chemistry.
Yeah,
See, 11 plus 2,
no.
which is
7
13.
plus 7. This is 7. 7 plus 7, which is 18. Right?
Sir.
Oh, okay.
Oh, you mean add the 7?
We love mathematics, but don't love chemistry. So all this one loves mathematics.
Oh, okay.
Then here, how many students love only chemistry?
12.
Then how many students love only physics and chemistry?
7. No. 12. No, 7.
How many students can love physics and chemistry?
Physics and
Is that
chemistry.
26? Is that 16 or 26 in the physics?
26. How many love only physics and
That's 26 plus 12.
how many love
38.
only physics and chemistry?
30,
38.
30, 30.
3.
38.
3.
Oh,
It's 30.
Yeah, no, it's 3. The
Chemistry only.
intersection. It's the intersect.
How
Between
many
two-
students have? Oh, chemistry only, physics and
Yes,
chemistry,
only physics and chemistry. So it's the intersect. That's 3.
which is 7.
3.
3.
Or 3.
Yes.
Yeah.
And how many love mathematics or chemistry? How many love mathematics or chemistry?
Mathematics all.
Oh,
Mathematics
all
or
mean?
chemistry. Union, you add
Is
them.
it?
So you add for mathematics and chemistry.
Mhm.
All together.
Mm. So whenever you hear, oh, it's maybe I'm right, I don't know, so you correct, it's union,
Mhm.
means union. Mm.
Okay.
How many love mathematics or chemistry?
50, 54.
1, 2, 3. Oh, 4 plus 2.
How many?
20.
Is it
25.
54?
Mm-mm.
25.
40.
Oh,
Okay.
mathematics and chemistry.
Oh,
19, 20, 25,
11, 17.
37.
Okay.
40.
We are going to end here. I'll leave you some homework. I'll send it on the group. So far, you surprised me. This is one of the first few classes that is performing. Usually most of the classes we have are BIDs, intended, but you are a good note.
Really?